I thought that today we'll be doing a little behind the scenes work to see that it's not just designing and making and sending things off, but it's going back and solving problems that come up. Now, as you know, most of my joysticks are designed for light touch, for folks with limited mobility or less strength. And but I also have folks who are, you know, don't have that issue basically. So I had a customer who had bought a couple of my sticks, and the stock sticks broke, and they were the palm sticks with the plastic shaft. And so I built them some steel shaft using Xbox, the Elite controller with the steel screw-on shaft. And those also failed, and they failed in slightly different ways, and I thought I'd show you how they failed. Well, first off, this stick is very obvious how it failed. Well, first off, the 3D print here gave way, and they put some glue on to try to repair it. And here you can see I've got, so there's an infill. This one wasn't done at 100%, and I'm doing them all at 100% now. But this was not at 100%, and it needs more support. So even though the brass insert held up fine, this heat pressed brass held up fine, it broke at that point. So I know I need to improve that connection there. And then this one was kind of a one-off design, but it had one of my custom boards printed in and, you know, assembled into the circle here. And you could see that it's seen better days. The glue on the bottom gave out completely. Two of the wires, the power and the ground, are torn off, and there's just a big globbly googly here, which is again, it's interesting because the metal shaft of the stick didn't give out, doesn't look like it, and the brass didn't give out. So that's good to know. And then on the interior of this one has this 4-point mounted design. This was originally going to be for my Palm 4s, which I never released. So the rest of it held up, but that didn't. So I knew that connection, if it's not a physical connection, if it's just an adhesive, that's just not going to work. The mechanical parts, the little M2 screws here, are fine. That piece is completely stable. So that's that one. Now the second one, and I have a different top than normal on here. This was one I sent out to them also, which uses the steel Xbox joystick. But in this one, I really super enclosed and added a lot of material to support the joystick. So when I got it back like this, I'm like, it looks perfectly fine to me. It looks good. But then I plugged it in, and it's flashing white and pink. Now, that tells me that it is going into its firmware update mode. When does firmware update mode get kicked off? When you first plug it in, and if you're holding the button down. So I'm like, oh, I bet you there's something wrong with the button in there. And sure enough, I noticed that the interior, it's hard to see. I realize it's hard to see for me right in front of it. But there is some black plastic in here that then presses this little black plastic lever, which presses the red button. The button itself is red. So the button is okay, but the little plastic part that presses down on that button to trigger it, which you see in all sorts of joysticks, that gave way. So this joystick failed. Now on the inside, and this one's kind of interesting, and again, when I talk about my R series, my repairability series, this is why I do this, so that I could do a post-mortem on these devices. Now you can see I really went pretty crazy when I designed this one. It's got a huge two-piece plastic around it, mounted with, these are M3 screws, so pretty serious base here. But the good news is I should be able to just take, let's see, if I'm lucky, depending on how much glue I use. And I've been really trying to avoid glue because it prevents me from repairing devices that can't be repaired. I mean, the chips and whatnot are the most expensive part in here besides the 3D prints. So if those parts can be recovered, they could be reused. It's the only time I've seen the microcontrollers themselves fail is the USB port. And the C ports on these cutie pies are far better than other ones. So yeah, I really went, and this feels like 2.5 millimeter, almost 3 millimeter enclosure, and this has got to be 5 millimeter there. So I really locked this sucker in pretty tight. So with this one, I think what I'll do is I will just have to replace the joystick mechanism itself. Oh man, I did go serious. These look like 8s. These might not be 3. These are probably M2.5, but these got to be 8 to 10. Yeah, it looks like a 10 millimeter, 10 or 12 screw. So that's going to come out. That's going to come out. Yeah, you can see when I built this, I was pretty serious about protecting that mechanism. And yet, at least my part didn't fail. It was the mechanism itself, which kind of stinks because I don't have control over that. Oh, these are long screws. I need a power screwdriver here at my desk. One more, it's almost there. Ugh. Ugh, now my hand's all tired. So here you can see the board is sandwiched in here, and the whole sandwiching idea seemed to work pretty well. So that pops out of there. That pops out of there. Now the stinky part with this one, when I originally designed it, is I had to kind of solder it in place when this plate was done. But I'll be able to unsolder this broken stick and then put a new one in, and that really should take care of this guy. So, and I am some of these ALP sticks, especially the green potentiometer ones, getting harder for me to source for some reason. And I did switch over to a new brand from what is it, CK Little Fuse. I think Little Fuse bought them, but I'm using them for all of my MIDI musical sticks, and I may try putting one of those in here because they're pretty strong. But the actual metal shaft of the stick is fine. It's just that little plastic right there that gave way. So I'll be able to repair this one, get this one back. This one I'm going to scrap. It's obviously not, this design is not strong enough, which I kind of figured, but I'll be able to pop the cutie pie out and reuse it in a replacement stick. So I'll probably build another one like this. So they'll have 2 of the same with the stronger design. And I might consider how I can more easily hot swap. See, this is using one of my custom printed circuit boards. I want to see if I could figure out a way to hot swap these, or not hot swap it, but non-soldered. But for now they'll be soldered. So there we go. I thought you might want to see the insides of some of the stuff and what happens when things go awry, and the continual improvement that you do to make sure that you have the best products possible. Thanks again for watching.